Imagine standing on a beach. The air is heavy. The horizon glows red. Waves no longer crash, they hiss. The sea is bubbling. Steam rises into the sky like smoke from a dying world. And then the ocean begins to boil. Within hours, the sound of life fades. Fish, corals, whales, gone. The vast blue that once covered 70% of our planet turns into a wasteland of vapor and salt. This isn't a scene from science fiction. This is what would really happen if Earth's oceans boiled away. Introduction. For 4 billion years, the oceans have been Earth's heartbeat. They regulate our temperature, create our weather, and support every living thing on the planet, directly or indirectly. Every drop of rain, every gust of wind, every breath of oxygen owes its existence to the oceans. But what if, suddenly, they vanished in a storm of heat and steam? To understand what happens, we must first understand how fragile the oceans really are. They are stable now, but only because Earth sits at a perfect balance between heat and distance from the sun. A small shift in either direction, and the water that sustains us could either freeze solid or boil into vapor. And in this scenario, we push that balance to its breaking point. Section 1. The moment it begins. The oceans begin to boil when the planet's average surface temperature reaches 100 degrees Celsius, the boiling point of water. But reaching that number globally isn't simple. For this to happen, something catastrophic must occur. Perhaps the sun grows hotter, entering a phase of solar expansion. Or maybe human civilization releases enough greenhouse gases to trigger a runaway greenhouse effect, similar to Venus. Whatever the cause, once temperatures cross that invisible line, the chain reaction begins. The first signs appear at the equator. The surface of the tropical oceans starts to shimmer with heat. Microscopic plankton, the foundation of the marine food chain, die first. Coral reefs bleach instantly, their colors turning ghost white. Fish suffocate as oxygen levels plummet. Sea turtles, whales, dolphins, creatures that have evolved for hundreds of millions of years, die within days. But this is just the beginning. As the surface water boils, massive clouds of steam rise into the atmosphere, forming an endless, dense fog. The sky darkens, trapping even more heat below. The oceans, once the planet's cooling system, now become its furnace. Section 2. The planet reacts. When the oceans start to evaporate, they don't just disappear, they rise. The air becomes saturated with water vapor, a powerful greenhouse gas. Each molecule of vapor traps heat that once escaped into space, amplifying the planet's fever. Within weeks, global temperatures skyrocket to over 200 degrees Celsius. Even the Arctic and Antarctic, once the planet's natural freezers, begin to melt and boil. The polar ice caps gone. The permafrost gone. Every frozen relic of Earth's history erased. As the oceans vaporize, atmospheric pressure increases dramatically. The sky turns a dense orange-gray as sunlight struggles to penetrate the thick, humid clouds. Rain stops completely. There's nothing left to condense because the air is already full of vapor. The hydrological cycle, the system that moves water through evaporation, rain, and rivers, collapses entirely. Weather, as we know it, ceases to exist. Storms no longer form. Wind patterns vanish. The Earth enters a new, stagnant state, heavy, hot, and suffocating. Section 3. The land burns. With no oceans to moderate temperature, the continents face the full power of the sun. Coastal regions, once cool and humid, become deserts of cracked salt and sand. Temperatures in former ocean basins soar above 300 degrees Celsius (570 degrees Fahrenheit), hot enough to melt asphalt and vaporize metal. Seashells and coral skeletons crumble into dust. Ships, oil rigs, and underwater cables, all now exposed, burn, rust, and disintegrate. Rainforests combust. Grasslands ignite. The atmosphere, rich in water vapor, creates brief but catastrophic bursts of lightning that spark infernos across the continents. Human civilization stands no chance. Cities that once thrived near coasts, New York, Tokyo, Mumbai, Rio, are swallowed by waves of heat. Even underground shelters offer no safety. The air itself becomes toxic. Oxygen levels plummet as plants die. With no photosynthesis, the very air we breathe disappears. Earth becomes a dry, burning shell, eerily similar to Venus. Section 4. The atmosphere breaks down. As oceans boil, the upper atmosphere begins to change dramatically. Steam rises higher and higher, reaching into the stratosphere, a region where it normally never belongs. There, ultraviolet radiation from the sun breaks apart the water molecules into hydrogen and oxygen. Hydrogen, being light, escapes into space. Oxygen lingers, but reacts with other gases to form compounds that slowly erode the ozone layer. Earth starts losing its water permanently. Every molecule that escapes is gone forever. The planet, once blue, begins to fade to brown and red. In less than a few million years, the oceans are gone entirely. Even the deepest trenches, once 11 kilometers below the surface, are dry. The Earth's crust begins to crack under the shifting pressure. Volcanoes erupt as tectonic balance collapses. The planet is scarred, its surface reshaped by fire and heat. And with no water to cool it, the planet's geological clock accelerates. Volcanic gases, carbon dioxide and sulfur, fill the atmosphere, thickening the haze even further. Earth becomes unrecognizable. From space, it no longer looks blue, but orange, smoky, and dead. Section 5. The science behind it. Could this really happen? Yes, and it nearly did. Scientists believe that about 2.5 billion years ago, Earth narrowly escaped a runaway greenhouse effect. If our planet had been just 5% closer to the sun, we might have become like Venus, a world where the surface temperature is over 460 degrees Celsius, 860 degrees Fahrenheit, and oceans never formed. Venus once may have had water too, but intense solar radiation boiled it away, and its atmosphere trapped the heat forever. Now it's a planet of perpetual fire. On Earth, rising greenhouse gases could, in theory, trigger a smaller version of this effect. If global warming spiraled out of control, or if a massive asteroid impact or nuclear war released enough heat and vapor, parts of the oceans could start boiling. But the complete evaporation of all oceans would require temperatures no natural human activity could cause. It would likely take a solar expansion billions of years from now, when the sun begins to die. That's when our star will grow brighter and hotter, eventually boiling the seas away for good. When that day comes, no life, not even bacteria, will survive. Section 6. The long aftermath. With no oceans left, the Earth enters its final phase. Rain no longer falls. Clouds no longer form. The sky is a permanent haze of toxic gases. The ocean floors, now vast plains of cracked basalt, become deserts stretching across the planet. Once mighty mountain ranges erode into dust. Life, as we know it, ceases to exist. But not all is completely lost. Buried deep underground, microbial life may persist in small, protected environments, near volcanic vents or within the crust. These organisms could survive for millions of years, clinging to the last traces of heat and moisture. Eventually, even they fade. The Earth becomes silent, dry, rust-colored, and still, a relic of what once was. From space, future travelers might see a scarred, empty world and wonder, was this place once alive? The answer would be written in the dust, the memory of an ocean that once covered everything. The oceans are not just water. They are memory. They are balance. They are the soul of our planet. Every drop connects to the rhythm of life, from the smallest cell to the largest whale. Without them, Earth becomes just another rock orbiting the sun. So the next time you see the sea, the endless horizon of blue, remember this. It is fragile. It is temporary. And one day, when the sun burns hotter and the sky turns white, it will be gone. But until then, it breathes for us. It cools us. It keeps us alive. Because everything, every breath, every cloud, every heartbeat begins with the ocean. Ending teaser. But if the oceans vanished into steam, What if the air itself disappeared next? Could life survive on a planet without an atmosphere? That is a question for another day.